The final thing we want to do with our moving charges is we want to look at another application called a mass spectrometer. This happens to be a very important piece of equipment, and I want you to know the physics behind it. So it turns out that it would look something like this. It would have three parts. You would take some sort of particle that you're trying to figure something out about, and specifically, you're trying to find its mass. These particles are way too small for us to ever hope to measure in traditional ways. So this mass spectrometer is going to be super important at figuring out the mass of very tiny particles. So in this case, we might have chlorine. The first step is you can't use this with a neutral particle, so you have to ionize your particle first. You have to have it either positively or negatively charged. In this case, we're going to ionize chlorine. It will then accelerate in a capacitor. It'll pop out the other side. We want to make sure that we get rid of any ions that are not moving at the proper speed. So we send it through a velocity selector, which we learned about in the last lesson. The ones that are moving too slow will be selected out. The ones that are moving too fast will be selected out. We will now know the exact speed of the particle when it emerges from the selector. It then moves into one more area, which is our detection area. So what's going to happen is it's a second independent magnetic field, which is going to bend it into an arc. There will then be a screen or some sort of other detection device that will let us know where that ion or other particle hit. And with chlorine, when we fire chlorine through, we will see actually two different spots, and only two spots, that it would hit. And that seems weird. How can there be two different spots where the chlorine hits? And it turns out it's because there are two different isotopes of chlorine. So when we look at our periodic table and we look at all the different isotopes, how in the world did they figure out how much these particles weighed? How did they get the mass of these particles? They did it with this mass spectrometer. By measuring the size of the arc, we are able to figure out the mass of the particle. Just like we did when we were doing the confinement of the antimatter. Okay, we know the speed going into here, we know the strength of the magnetic field, and we know the charge. So boom, we've got the force. Once we've got the force, we can use our velocity, and we could use the radius that we measure for our detector to get the acceleration. Once we have the acceleration and the force, we can figure out the mass of our particle. It is amazingly complex, but at the same time, pretty simple in terms of how this process is going to work. All right, and then once we have the mass, we know the mass of the different isotopes. And we can do this with great accuracy. Okay, when you do this, sometimes you'll see that one of these dots gets a lot more hits than the other. And the reason for this is because the two isotopes, or more isotopes for some elements, are not found in the same abundance. So with chlorine, we have two different isotopes. One of them is going to be more prevalent than another. You might have learned this when you were taking your AP chemistry class. Okay, you learned about the chlorine. When they looked at it, they would see two different spikes in terms of that mass spec, in terms of how bright. And you can see that one of them, there's not too many, and one, there's a lot more. All right, about 75%, 76% of chlorine has a mass of 35 atomic mass units, and about 24% has a mass of about 37 atomic mass units. So again, it's called the mass spectrometer. It is a very important scientific device, and it works off of force magnetism. If you wanted to buy one, you could buy one on Amazon for about $11,000, so probably not something you want to have in your basement. However, you can see that it's used in a lot of different areas, okay, from uncovering fingerprints somehow, detecting disease, I guess that's kind of important, and you can see how the market for Spec 20s is increasing as we get more and more sophisticated with our high-tech equipment. So anyway, I hope you guys understood how this worked. There's a practice problem online for you to try to make sure that you can go through the math on your own for the Spec 20.